So this is a rocket quiz recording. First part says draw a label, a simple diagram. So here's a simple drawing of the rocket ship, SpaceX, whatever. This will be planet Earth. So this is a rocket ship. This is a planet Earth. And so for drawing a free body diagram, we would put gravity is going down, force drag going down, force thrust to get to the atmosphere is going up, and acceleration and velocity are both going up. So moving on to the second part, it says define the variables in equation 12. So this is equation 12. M d squared y dt equals negative k capital M y squared. So we just go with this equation. So for k, it is constant proportionality. Y is distance from object to center of the earth. Pardon the bad writing. Capital M and lowercase m. Capital M is mass of the earth, and lowercase m is mass of rocket. So these are basically the four variables that you would encounter in equation 12 on page 255. So now to the next portion. It says explain where equation 12 comes from. Oops. So first, let me depict Newton's universal law of gravitation. So this is Newton's universal law of gravitation. And this is equation 12. This is part of equation 12. So it might look very different, but they're actually very similar, and we'll explain why. M1. So this G is gravitational constant. M1 is mass of object 1. M2 is mass of object 2. And D is distance. So for this in equation 12, we're going to K. So again, K is constant proportionality. Capital M is mass of Earth. Lowercase m is mass of rockets. And Y is distance of objects to the center of the earth. But I'll just write it as distance of the object to center of the earth because the whiteboard does not have enough space. So this is Newton's universal law of gravitation, and this is equation 12. So here's G, gravitational constant. K is constant proportionality. M1 is mass of object 1. M2 mass of object 2, and D is distance. Capital M is mass of Earth. Lowercase m is mass of the rocket, and Y is distance of object to the center of the earth. Oops. So now going on to explain how to get from equation 12 to equation 13. So let's start from equation 12. This is our equation, d squared y and dty equals negative k m y squared. So now what we could do is divide both sides by m. Once we do that, we'll get this. divide both sides by m. From doing that, our equation will now be d squared y over dt squared equals negative k capital M y squared. So now at ground level we set y is equal to r. And now solving for k, we get k is equal to gr squared over capital M. So for our derivatives, we have d squared y over dt squared is equal to negative gr squared over capital M times M, capital M, and y squared. So what we could do now is cancel out the m's, as so. And now what we're left with is d squared y over dt squared is negative g r squared over y squared. So this right here is equation 13. Equation 1-3. So now, for part A, explain the part A of the problem. So this is equation 13. Equation 13 is d squared y over dt squared equals negative g r squared y squared. So what we could do now is multiply both sides by 2 dy dt, 2 dy over dt, and we'll do it like this, times 2 dy over dt, 2 dy over dt on both sides. So this is how it looks like with multiplication. So now we will set the derivative and get the constant c. So we'll get dy over dt squared is equal to 2 gr squared over y plus c. So now what we could do is, for this part, dy over dt, we can substitute it with a v. Substitute with a v. And now it'll look like this. So say v, substitute v for dy dt, but since we have the parentheses squared, it's v squared equals to 2 gr squared over y plus c. And so for a constant equation, it's c is equal to negative 2 gr plus v squared naught. So plugging this equation into c, we end up with this. Negative 2 gr plus v squared naught. And that is how we get the equation. So now for part B. This might take a long one. For part B, we have these hints. We have y is equal to infinity, and v is a positive number more than, it's a real number, but we don't know where it is. So starting from this equation, v squared equals 2 gr squared y minus 2 gr plus v squared naught. This is our starting equation as such. So what we could do is, to get rid of this v squared, specifically only the squared part, we could take out the squared and put the square root on the other side. Yes, like that. So now it's like this. V is equal to 2g r squared over y minus 2gr plus v squared naught. So now we set v is equal to 0. Well, because yes, v is equal to 0. It's a real number that's more than 0, so we just set it like this. So for v is equal to 0. So we just set 0 is less than 2gr squared minus y minus 2gr plus v squared naught. And so in this part it says the hint is y is infinity. The only problem is when we plug in y, if we plug in y into the calculator, it will turn out as error. But what number infinity can we plug in? Well, if you plug in 0, it'll cancel out and just be like this, canceled out this part of the equation. So now our equation becomes 0 is less than negative 2gr plus v squared naught. So we're going to do some manipulation. We're going to subtract this v squared naught on both sides. V squared naught. Now it's going to become v squared naught is less than 2gr. So again, we have v squared naught is less than 2gr. So again, to get rid of this squared, we could just square root the other side, and that's what we're going to do. And so, just as we have done as the first part, it is now like this. It is our equation. So our answer is v naught is less than square root of 2gr. And this equation is escape velocity. Escape velocity is our equation. So now for some calculations using the escape velocity formula, we shall continue onto two parts. So for part C, we are given g is equal to 32 feet a second. Radius is 4,000 miles. And conversion, 1 mile is equal to 5,280 feet. 280 feet. And so using the escape velocity formula as is, it is just simple plug and chug, as some people say, or whatever they say it is. So it'll be 2 times g, which is 32 feet a second squared, and it'll be r. So we just put in 4,000 miles. 4,000 miles times 5,280 feet. And remember, it's a square root. So after doing all this, it will be v naught will equal approximately 36,765.2 feet a second. So that's the answer, but since we're going to convert the units, we shall do some dimensional analysis. So 36,765 feet a second times 36 feet an hour divided by 1 foot a second times 1 mile an hour. 1 mile equal to 5,280 feet an hour. We just cancel these things out. Dimension analysis. You want it to be miles an hour, so that goes in the top right part, which is last, which will be 25,067 miles an hour. And so this is part C of the problem. Now for our last portion, we shall do part D. And I apologize for the sloppy penmanship, but my arm hurts. And so now we have given these variables. G is equal to 0.165 grams. But from the previous equation, our g is also 32 feet a second. And now the radius is different. The radius is now 1,080 miles. 1,080 miles. And so again, 1 mile equals 5,280 feet. So again, we're going to use the same formula, escape velocity formula, which is 2gr square roots. So again, we're going to plug and check, plug and chug, whatever this terminology is called, we will just use it. So 0.615 grams times 0.32 feet a second. And the radius is 1,080 miles times 5,280 feet. So in square roots, they shall give us V naught is 7,750 feet per second. So this is our answer in feet per second. We will do dimensional analysis again for miles per hour. So our answer in feet a second was 7,760 feet a second. So using dimensional analysis, we shall do this. Feet per hour, divided by 1 foot a second times 1 mile an hour. 1 mile is equal to 5,280 feet per hour. So again, all these cancel out. Feet a second, feet an hour. We're left with miles per hour, which will equal 5,291 miles per hour. And so I hope this explanation was sufficient for the grading criteria, and I'm sorry for the penmanship, but I try my best in this framework for the photo, and thank you.